Buenos días. Sean todos bienvenidos otra vez aquí al segundo día de las conferencias. Principalmente las conferencias del día de hoy están orientadas al tema de, o con ISBSG. Entonces, pues creo que van a estar también muy interesantes. Entonces, sean bienvenidos y pues demos la primera conferencia para que empiece el presidente de ISBSG, que es Harold.
Does it work? Okay. Good morning, everybody. I'm very happy to be here. This is my first time in Mexico. I'm looking forward to the second day of the conference. I hope you all feel the same. Let's start with a little bit of an introduction, because probably you don't really know me, or maybe never seen something that I did. My name is Harold van Heeringen. I live in the Netherlands. And I already have over 15 years of experience in software estimation, metrics, and these type of activities. At the moment, I'm the ISBSG President, and I work also in NESMA, COSMIC, ICEA, and a number of other organizations. And I have to apologize a little because I have a problem with my voice, so it will turn over sometimes, maybe. I want to talk to you about software estimation, software cost estimation. For a long time, I have been working here in the industry. I've seen software cost estimation being underestimated, let's put it like that. So it's not a formal profession yet. While in other industries, we see that it's a really relevant profession. So I'm going to talk to you a little bit about industry maturity, about software estimation, how it looks now in practice, about some of the basics of software estimation. I want to introduce to you the software cost estimation body of knowledge, which is a new body of knowledge that has not existed before. I'm going to talk a bit about ISBSG. Sorry about that. Problem. And some conclusions. So, cost estimation, what are we talking about? Cost estimation is actually approximation of the cost of a program or a project or operation. The cost estimate is a product of a cost estimation process. So there should be a process in place. And often cost overruns, whenever I see cost overruns reported in the media, which happens a lot in software, I almost never see that the cost of this overrun was the bad estimate, which often happens. So the estimates are low, and then the cost will be overrun because it was not realistic. So a cost estimator is a person or a group of persons that prepare the cost estimate. And well, there are different types of cost estimates in different types of industries. In most of the industries, this is a recognized profession, but not in software. In software industry, you will never or almost never find anyone says, hey, I'm a professional software cost estimator. There are a few exceptions. I know Dan employs a few of them. But in most of the industry, you never will see these people. Even in the large IT companies that we all know, the estimates are made usually by project leaders, developers, testers, architects, people that work in the projects. They just ask, okay, how much time do you think that this will cost you? We have a bunch of requirements. Just look at it and see how much time it will cost you. Make an estimate based on your experience. So we call these expert estimates. They're usually made by having a work breakdown structure to understand the complete task, make small parts of it, and then put estimated hours against them. This is the estimating maturity model, which is developed by Dan Gallerath, who is also here in the room. And I've used this estimation maturity model already a lot of times in my presentations because I think it's really powerful. It shows that that there are actually steps in estimation maturity, and if you want to go to a higher level of maturity, at some point in time, you have to start measuring the size. If you look at the model, you see that level 0, level 1 estimates, there's no sizing. It's just going from requirements to effort to cost. The problem is that it's not based on data, it's not based on size, it's not based on models, it's not based on actual history. And because of the human bias, which means that humans tend to underestimate things, they just think of the first possible solution that something will be ready, which is not usually very realistic. So the low maturity methods you can use, but we will see also later in the presentation that it's really dangerous because the risk on cost overruns are very high. If you look at the level 2 to 5, there are sizing involved, at least some form of sizing. You can use function points, you can use cosmic function points or NESMA function points or any other recommended functional size measurement method, which of course here in Mexico will be cosmic, being the national norm. And there is some form of process involved to come from your size to your estimate. So the bias, the human bias mitigation that makes sure that you don't underestimate your project starts at level 2 and will be solid at level 3. So you need estimation maturity of, let's say, level 3 to make sure that your estimates are going to be at least some form of realism in there. So if we look at the maturity in the software industry, the maturity, the way I see it, is quite low still. So estimation and performance measurement processes are not really implemented in most of the organizations. Not the big ones, especially not the small ones. So organizations, they don't know the size of their applications. They don't know if the cost that they're spending is in line with industry averages. They don't know their productivity even. They don't know how many hours per cosmic function point they spend on Java projects, Oracle projects, other types of projects. They don't know their time to market. How fast can they deliver 100 function points, 200 function points? They don't know their cost efficiency compared to the market. They don't know the quality. Sometimes defects are measured, but not against a unit of measurement. So most organizations, they really have no idea how they are compared to their peers or to other parties in the industry. This is very strange because in a lot of other industries, this is well known. It's so well known that in these industries, they will use, let's say, the cost per square meter in their contracts. Well, we've seen a presentation of Francisco yesterday about the cost per unit. That would really help also in our industry, because it will be possible to compare. So what is the reason for low maturity? Well, like I just said, so software measurement is not really common still in a lot of places. And to deliver new functionality to your customers becomes more and more important. It's crucial, sometimes even for survival of your company. And productivity is very important in that. To have a higher productivity than your peers will help you survive. So productivity is defined as output divided by input. Well, input, usually in this industry, we measure in effort hours. Effort hours spent on software development or maintenance and support. But the output is more difficult to measure. Not for maybe the people here in the room who are maybe experts in cosmic functional sizing or other sizing measurement methods. But for most of the, let's say, the outside world, it is difficult. So functional size measurement is really important. You can do it very early in the project, and because it's independent of technological requirements, you can compare stuff. So, and I usually compare it with walls. So if you have the square meters of a wall, you can compare that, the number of square meters between a brick wall and a glass wall, just like you can compare 500 function points of a mobile app with an ERP system. The main point is that it's objective, repeatable, and defensible. So two people measuring the same thing come up with roughly the same number. Then you can use it in contracts or in estimation. So if we look at a number of very important objective software metrics, we look at productivity, hours spent, cosmic function point, cost efficiency, the money spent per cosmic function point, time to market, how fast is a cosmic function point delivered, and quality. How many defects do you find and resolve during your project? Per, for instance, 1,000 cosmic function points. So if you have these metrics, you can compare them because it's a standard. You can use it for estimation, for contracting, for project control, for benchmarking, supplier performance measurement, and all these type of things. So for estimation, we're talking about software cost estimation here today. It's very important for the success of your project. The estimate is the basis for a lot of things. The business case, the planning, the proposal, the financial win or loss that you make on your project, the claiming and releasing of resources, alignment between the IT and the customer, progress reports, all these type of things, they are kind of depending already on your estimate. If your estimate is wrong, everything else will probably also be wrong. So without a good estimate, you're already in a danger zone. You might fail. So in the IT industries, we have the problem that the measurement is not really mature. The estimation is not really mature. So that makes it possible for the customer to put the prices down, to put pressure on the suppliers to lower the price. So it should be cheaper. It should be faster. But I'm not going to give you the complete requirements yet because I don't know. And I want an early fixed date and fixed price quote. And this is just sent out into the industry, just waiting for the proposals to come in. And then you have the problem, because the IT supplier, they don't know what exactly does he want. And they have their expert estimates, but well, if the requirements are not complete, how are you going to make a good estimate? And besides, they have no idea how productive they are, how cost efficient they are, etc. So it's kind of difficult for them to push back. So you're pressured that it should be cheaper, and you have no good estimation techniques. So what do? Okay, then change your offer. So this also results in optimistic estimates being more rule than exception in the industry. And the problem of optimistic estimates, I will show you in this figure. We have here the optimistic estimates, realistic estimates, and pessimistic estimates. And these are additional costs. So once you start with a realistic estimate, you will probably not have additional cost because your estimate was realistic. So it will be approximately done against that cost. If you start with optimism, at some point, things will go wrong. The project manager will find out, hey, we're behind schedule, we have to do something, we're not going to make it, what are we going to do? And sometimes people are just added to the team. We've seen yesterday in Paula's presentation, that's usually not a good idea, making just the project much more expensive, not really faster. Extra management attention, more defects, because you put pressure on your team. And if you put pressure on the team, you will get them to work overtime. They will go to make mistakes. Even worse, their code quality will be lower, maintainability will go up, and every defect that is made is found in testing, has to be resolved, tested again. So a lot of extra work because of that. So once you have, maybe just give an example, if you should have started with an estimate of 1,000 hours, but you estimated 800 hours, you might end up having a project of 2,000 hours, right? Additional cost. Well, if you're on the other side, you're pessimistic. This is Parkinson's law. The extra hours that you get will probably be spent. So if you should have estimated 1,000 hours, but you estimated 1,200 hours, you're probably going to use 1,200 hours. Do some extra testing, some extra documentation, or just find some other way to spend your time, I don't know. And that's in principle not a bad thing, because it's still predictable. But in the industry, it might, of course, result in projects that you don't win, because all your competitors are on the left side of this figure. So only very mature customers also understand this, right? So we've seen yesterday a presentation of Francisco that you have if you ask for the different quotes, cost per function point, you still have to make sure that the lowest quote is somewhere here in this range, in the reality range. Because if it's somewhere here, probably better not to take it. And this very important concept that you have to remember, that you have to avoid optimistic estimates at all time. Okay, so basically there are two ways to estimate. I already explained that. So you have the level 0, level 1 estimate that goes from requirements to effort and then to cost. And the 3, 4, 5 levels, first including size, and then using models and data to go to effort and then go to cost. With the additional advantage that you can use this also for estimation and benchmarking and all types of other processes like I explained before. Benchmarking you can do against the ISBSG data set, size you can use, for instance, COSMIC or IFPUC or NESMA. So if you look at your maturity levels, then you have to be careful because your maturity level will probably result in extra cost if you're not careful. So expert estimates level 0 and 1 and 2 might be on the left side of this figure most of the times. While the realistic estimates, I think, will be much more likely to come with the level 3 to 5 estimate. Okay, so what I just explained was that it's very important that your estimation maturity will go up because that will make sure that your project cost will be predictable and reliable and not going higher than you expect. Your project overruns will be much less. To illustrate this in the industry, NESMA and ICEA, together with a number of other organizations, like also IFPUC, COSMIC and ISBSG, are supporting this, we started the software cost estimation body of knowledge, which is, let's say, a framework with a lot of software estimation laws and methods and knowledge included. And for those who don't know the ICEA, International Cost Estimation and Analysis Association, which is basically based in the US. We just had the conference of the ICEA just a couple of months ago, and the software cost estimation body of knowledge had a separate track there. So there are like hundreds of people there, and we had a separate track explaining the software cost estimation body of knowledge. Because also in these cost estimation associations, the software part is often the difficult thing. They can estimate plants, they can estimate aircrafts, rockets, all kinds of things they can estimate pretty well. But when it comes to the software part of all these things, they're always struggling. So NESMA and ICEA are driving this. Other organizations are supporting this. We are going to try to make the software cost estimator a recognized profession in the industry. So we want to have it recognized, first of all, as a certified profession, and then also convince the industry that you need software cost estimators to have a realistic estimate of your software cost. And preferably, we also want to tell the industry that there is such a document as a baseline of estimate, where you can put all your estimate assumptions, your data, your everything that you have used to come up to the estimate. You can put it in a baseline document so that you can always come back to it later. Everybody understands what you did in the estimate. So there are some local cost estimate certifications. I think there is one in China, for instance. But there's not yet an internationally recognized software cost estimation certification. And we're going to try to certify the first people in the next ICEA conference, which is in May in Florida, I think. Okay, I've been over this. Going to be 2 levels, foundation and expert. And in this slide, I just want to show you a number of modules that we already presented at the software cost estimation track of the ICEA conference. And you can see here, for instance, that estimation maturity is a separate chapter here. Well, then I would like to talk a little about ISBSG, being here as the ISBSG President, because we also support this initiative. And for those of you who don't know the ISBSG, the International Software Benchmarking Standards Group, it's based in Australia. We have a number of not-for-profit organizations who are a full member, and your local association is one of them, the AMMS. And other organizations are NESMA, IFPUG, FISMA, China SPI, GUFP ISMA from Italy, JFPUG from Japan, Swiss ICT, and some commercial organizations like Gallereth and Kexin and LIDA. And COSMEC at the moment is a bronze member. So not a full member yet, but bronze member. And we have 2 repositories of a lot of data. So we have maintenance and support with over 1,000, over 1,100 applications. So you can see how big is an application, how much effort was spent on incident management and those type of things. And we have the most important one is the new developments and enhancement repository with over 8,250 projects at the moment, which can be new developments, enhancements, or releases, or sprints in case of agile development. And we get the data from the industry. Everybody can submit industry. If you have some cosmic data, we yesterday heard the video announcement of the Cosmic President, Frank Vogelzang, who also happens to be one of my colleagues in the company I work for, by the way. So it was kind of confronting, but okay. So we saw the video message, and he also applied to you, if you have some data, please submit it. Because you will be helping the industry, and also you will get something in return. We will give you a free benchmark report in return, where we compare you to some of the peer groups that are there. This is an example of some graph from one of these reports. You can see here the productivity rate, and we do that also for the other metrics that I mentioned. ISBSG mission is quite simple. We just want to improve the decision making in the industry by providing data to make better decisions. And we want to have data from the industry that is current, and we validate it. That's representative of the industry needs, and from a lot of different organizations as much as possible. So how does it look like, ISBSG data? It's just a big Excel file. Big Excel file with more than 8,000 rows, more than 250 columns. And of course, not all the data is filled in all of these columns, but usually a lot of relevant data is there. And you can just filter it and slice and dice and make your own analysis, put it in pivot tables, do all kinds of analysis on it. And you can see here I have selected on Cosmic here, just only selected on Cosmic, nothing else, just to give you an idea that there's a wide range of technologies there, a wide range of size. And I think at the moment the database has over 500 Cosmic projects, but we're going to add a lot of them in the next release. Well, what can you do with it? For instance, if I just come back to this graph, you can make a selection in the database. You select data quality A or B. For instance, you only want to consider projects after 2012. Project type enhancement, because it's not new development. Java project, and you want to have NESMA or IFBUG or Cosmic. Doesn't matter, you can do your own analysis. In this case, NESMA or IFBUG. And if you just do some basic statistics on the data that you have then selected, you can see I have 166 projects. The minimum is 4.2, the maximum is 50.3, and you have, what I always do, I look at the percentiles, and especially at the median, because the median will consider the middle of the data set, and possible outliers on either side of the distribution will not have a big impact. In this case, median is almost the average, so data is probably normal distributed. So then you also can consider what is going to be my landing zone. What do I think is realistic? I usually take the P25, the median, and the P75. And well, in my opinion, then you will be very close, in this case for this project, in the landing zone, for the realistic estimate. Of course, there are other techniques, and you should also do your expert estimate to see if they are in line with each other. But if you don't have any other information and you have to estimate a new project and you don't have your own data, you can use this type of data to make some analysis. Okay, so if you're an AMMS member, you can actually get a discount on the products of ISBSG. I just put here some of the things that we have. We have a lot of these special analysis reports that are most of the times very interesting because it analyzes some part of the industry. For instance, what I thought was very interesting was the government versus the non-government performance. There are some differences there. I'm not going to give away the clues there. And the development and enhancement and the maintenance and support data, of course. So I've come to the conclusion of this presentation. I hope I have convinced you that it's important to raise your industry, your maturity level in estimation to a higher level. That it will actually also save you a lot of money to do that. That way you will have to start functional sizing, cosmic functional sizing being perfectly okay. We're trying, to make it a profession. So all you guys who are in software cost estimation, I invite you at least to study the software cost estimation body of knowledge once it's released to certify in this area. And ISBSG is one of the supporters, and I hope you will also support us by providing us with data or to help Francisco AMMS to collect data from the Mexican industry. Okay, thank you. Any questions?
Agradecemos a Harold Van Heeringen, presidente de la ISBSG, por su conferencia. Un aplauso, por favor.
Oh, thank you.